Welcome back. We're going to talk some more about absolute values and how to solve equations with them in this video. In the last video, we introduced what an absolute value is. Anything inside those vertical bars, those absolute value bars, it turns whatever is inside positive. And we learned the 3 steps to solving an equation with an absolute value in it. Step 1 is to get anything inside those bars by itself on one side of the equation. Step 2 is to write case 1 and case 2. And step 3, once you've solved everything, check your solutions and make sure they work. We did an example like that in the last video, but we've got some more here. So let's go ahead and start with multiple choice problem 2 here, which you can see on your notes right about there. What is the solution to the absolute value of 2x plus 5 equals 15? So we'll write out our steps. Step 1 is to get the absolute value stuff by itself on one side of the equal sign. Right? So this is what we have. The only thing on the left side of the equal sign is the absolute value of 2x plus 5. There doesn't appear to be anything else there, so we're good for step 1. Ding! Didn't even have to do anything. Awesome. Step 2 is to write case 1 and case 2. What goes in case 1 and case 2? Well, starting with case 1, the first thing that this means, we copy down this equation without the absolute value bars. So this just becomes 2x plus 5 equals 15. Case 1 is always this equation once you've gotten the absolute value by itself. We didn't have to do anything to do that here. 2x plus 5 equals 15. Same thing we had, just without the bars. Case 2 is exactly what you wrote in case 1, except everything on the right side of the equal sign has the opposite sign. So since this is a positive 15, for case 2, that's going to be a negative 15. Everything else is the same. So step 2 is really just writing case 1 and case 2. The only step that's left is to solve each of these 2 equations for x, and then plug them back in to here and make sure that they work. So, to get the x by itself in the case 1 equation, let's move that 5 over first. Since it's a plus 5, we subtract 5 from both sides. The 5's are going to cancel out. That'll give us 2x equals 10. Divide both sides by 2 to get the x by itself, and we get x equals 5. Okay. The order in which you do these steps, well, step 1, step 2, step 3, it has to go in that order. You can go ahead right now and check whether this is a solution by plugging x equals 5 back into here and seeing if what you get works. I like getting both of my potential solutions first and then checking them both afterwards. But it's up to you, whatever you feel more comfortable doing. The reason I like doing it this way, where I get both solutions first, the steps we took here to get x by itself, they're the same steps. But since this is a negative 15, we're going to get a different value for x here. We subtract 5 first. This is going to give us negative 20 this time. Negative 15 minus 5 more. Dividing by 2 gives us x equals negative 10. So these are the 2 values that we think x could be. We need to check them by plugging them in one at a time back into the original equation to make sure it works. And we'll see what I mean by that. So let's plug x equals 5 in here. So we need to check 2 times 5 plus 5. The absolute value of that. Does this equal 15? Right. This is 2 times 5, that's 10. Plus 5 is 15. So, does the absolute value of 15 equal 15? Yes. This solution works. X equals 5 is a good solution. Now we check this one. This is the absolute value of 2 times negative 10 plus 5 equals 15. Okay. Same idea, we just find out what number is in this absolute value by multiplying 2 times negative 10, which is negative 20, and then adding 5. Negative 20 plus 5 is negative 15. So we have the absolute value of negative 15 equals 15. Is this true? Yes. That's what the absolute values do, right? They take a negative number inside and make it positive. So this solution also works. So x can be 5 or negative 10, and it still works here. And that's because since something with x is in the absolute value, whether it's positive or negative, it works both ways. So the answer is x can be 5 or negative 10, and in the notes there, that's going to be answer choice B. That's going to be B. Does it look like a lot of work? I guess that's intimidating if you write it all out like that, but it's just 3 steps. And the first 2 steps usually aren't going to be that bad. Step 1, sometimes you don't have to do anything at all. Step 2, writing your 2 cases. That's a little different. This is new, right? But once you've got your 2 cases, solving those for x, you're probably familiar with how to do that. You've had experience doing that in the past. You might screw up once in a while, but this is nothing new. And then plugging those numbers back in to get our answer, we were talking about that in our first video. So you have some experience doing that as well. So as long as you know what the 3 steps are, and those are in your notes, right? Problems like this are doable. You can do them. Let's talk about another one. Next, we've got example 3, this bottom one right here. We want to solve the absolute value of 6 minus 4t plus 5 equals 0. Okay, step 1. We want to get whatever is inside the absolute values by itself on one side of the equal sign. Now, in the examples we've done up until now, it already was. We never had to do anything for step 1. But take a look at what we got here. The equal sign is here. The absolute value is on the left side, so is this plus 5. What that means is this plus 5 gotta move. We gotta move that 5 over before we can do anything else. So step 1 is just subtracting 5 from both sides. Those 5s are going to cancel out. So we have the absolute value of 6 minus 4t. Sorry, I want to make that a little bit clearer. Equals negative 5. So let's take a look at what we got here. Now, we could, at this point, step 1 is done. We could move on to step 2 and write our 2 cases and solve them and check our answers. But let's take a little bit closer look what we have here. We've got the absolute value of something. We know it's 6 minus 4t, but we don't know what t is. But it's the absolute value of stuff equals negative 5. Now, if you took notes in the last video and you've got those notes, we said an absolute value can never be what? an absolute value can never be negative. But take a look at what we have here. An absolute value of something equaling a negative number. But absolute values can't be negative. So what does that mean? How can we solve this? Well, if this happens, if you've got the absolute value of something equals a negative number, that's a pretty big shortcut because that means there's no solution. When you're dealing with absolute values and solving equations, be on the lookout after step 1 for something like this. If you've got absolute value of something equals a negative number, stop. You're done. No solution. The fancy mathematical version of no solution is a 0 with a line through it. This here. You don't have to know that. If you write no solution or absolute values can't be negative, I'll know exactly what you're talking about and that'll be right. But that's a nice, nifty shortcut to look out for when you're solving problems like this. So, that was quick. Next is example 4. It's asking what is the solution to, which is the same thing as solve. Okay? By solution it means what value of x is going to make this work. So we're still solving. 5x minus 2/3, the absolute value of that, plus 7 equals 0. I think this might be a good time, if you've been paying attention, taking good notes, do step 1 for this problem and see what it gives you. At least do step 1. If you want to keep going, you can. But at least do step 1 for this problem and take a look at what you got. Pause the video if you need to. Come back when you've got it. All right. That's what step 1 looks like. We have to move this plus 7, right, to get this absolute value by itself on the left side of the equal sign. So we subtract 7 from both sides to move it over, and we get this. The absolute value of 5x minus 2/3 is equal to negative 7. Now, you might be thinking, there's a fraction in here. I don't like fractions. I hate this. Why is math so hard? Maybe you're not thinking that. But I'll tell you right now, the rest of this problem is very easy. See anything familiar that we've already talked about today? We have the absolute value of stuff. It doesn't even matter what it's in here. It's an absolute value of something that equals a negative number. We've got the same thing that we do here. This, again, is no solution. And maybe giving you 2 examples back to back where that happens is overstating how often that can happen. It's not super often, but it's important for you to recognize because you could continue doing steps 2 and 3 here, writing your cases and all that. What you'll find is neither of the values you get for x are going to work when you plug them back in. And you'll feel like you wasted your time. If you notice right after step 1 that there's no solution, you can save all that time and effort. But that only happens after step 1 if you've just got your absolute value here and it equals a negative number. That's the only time that happens. Notice here, we didn't have that happen because it equaled positive 15. Now, when we write cases 1 and 2, case 2 has negative 15 here. But when we write our 2 cases, those absolute value bars go away. That allows us to solve both of them. Okay. Here, those absolute value bars are still here and it equals negative 7. That's why there's no solution. Okay. So, last example. Last one of this video. Example 5, we want to solve the absolute value of 8 plus y equals 2y minus 3. And it even tells us to check our solutions when we're done. So, let's try this out. Step 1. Step 1, remember, is to get the absolute value by itself on one side of the equation. The absolute value of a plus y appears to be the only thing on the left side of the equal sign, so we're already good. Now, let's go ahead and look, just so we don't get bamboozled again. Do we have an absolute value equals a negative number? Well, we've got 2y minus 3 here. And we're trying to solve this. We don't know what y is equal to. It's possible for some values of y that this is a negative number and it won't work. But there are values of y where this will be positive. So we can't just say no solution here. That would be the easy way out. It would also be wrong. So we will go ahead and do steps 2 and 3 here. Step 2. Step 2 is to write case 1 and case 2. Case 1 is exactly what we see here, but without the bars. So this is just 8 plus y equals 2y minus 3. And I'm actually going to write case 2 in a different color, just to make it easy to see the difference. Case 2 is going to be what we have here, kind of. The 8 plus y stays the same. But everything on the right side gets the opposite sign, right? It's just like here. This 15 became negative 15 for case 2. Now, in all the examples we've done so far where we went through the whole problem, we only had like a number on this side, so we just turned it from positive to negative, or from negative to positive. Here we've got 2 terms on this side. They both have to get the opposite sign. So 2y minus 3 becomes negative 2y plus 3. Every term on the right side of the equal sign needs to get the opposite sign for case 2. Okay. So that's case 1 and case 2. That's step 2. Step 3. We solve each of these equations for y, and when we're done, we'll plug them in and see if they work here. So, let's go. Okay, case 1, we've got y's on both sides of the equal sign. So what I want to do is get the terms with y on the same side and the terms without y on the other side. So I'm going to subtract y to bring all my y's over here. I'm going to use a little bit of an advanced technique here. You can do 2 steps at once. I'm moving my y's over here. I'm going to move my numbers without y over here. So this minus 3, I'm going to add 3 in the same step to both sides. If you're not comfortable doing that, do that in 2 separate steps. That's perfectly fine. I can see I'm going to need to save space here. So these cancel and those also cancel. Here we've got 8 plus 3 is 11. 2y minus y is y. So we get 11 equals y. Now we solve case 2. Steps should be the same. Moving the y's over here. Moving the numbers without y over here. Y's cancel, 3's cancel. 8 minus 3 is 5. Negative 2y minus y is negative 3y. So the reason this isn't just y here is because this was a positive 2y. We changed that to a negative 2y. So negative 2y minus another 1y gives us negative 3y. So for this one, we still need to do something to get the y by itself. We don't add 3. Don't add 3. This is negative 3 times y. We need to divide by negative 3. Those negative 3's cancel. Y equals negative 5 over 3. Negative 5 over 3. Okay. So, we've got two different values of y here. We need to check to see if they work here. So, actually, I'll let you in on a little secret here, since this is the last example and we haven't seen this yet. The solutions that you're testing, you can do them like we did here, plugging those numbers in and making sure that what you get equals. You could also say, as long as what you have on the right side is positive when you plug this in, it will work. If when you plug that number in you get something negative on the right side, it won't work. So, let's plug y equals 11 into just the right side here. Into 2y minus 3. We're going to plug 11 in right here. If we get something positive, then that means this is a solution. If we get something negative, it means it's not a solution. Okay, so 2 times 11 minus 3. Okay. We're just trying to see whether this is something positive or negative. It actually doesn't matter what this side is equal to. It doesn't make a difference. So this is 22 minus 3. Which is 19. Which is positive. And that's good. That's what we want, right? We said as long as what this is positive, which it is, it's 19, then this is a solution. Great. Let's check the other one. Negative 5 over 3. So again, we're just plugging that into the right side here, so that negative 5 over 3 will go right here. So we have 2 times negative 5 over 3 minus 3. Now this is kind of a nasty fraction. Multiplying that out can be a little tricky, but check out what we've got here. This is 2 times a negative number. Positive times negative is negative, right? And then we're subtracting 3 more. We're going further into the negative numbers. So is this going to be a positive or negative when we're all done? It's going to be negative. And I hope it doesn't bother you. It doesn't matter what the negative number is. The fact that it's negative means this is not a solution. So even though that's what we got when we solved case 2, since that made the right side a negative value, it's actually not a solution. This is the only one. Y equals 11 is the only solution to this example. So, over the past 2 videos, you've learned a lot about absolute values. You've learned what they are. They turn everything inside positive. You learned how to plug numbers in and do expressions to evaluate with them. And we've done a few examples here of how to solve equations using absolute values. It's a 3-step process. Get the absolute value by itself, write your 2 cases, solve, and check. Unless you have an absolute value equals a negative number, in which case you're done, there's no solution. And you've found that the reason why we check in part of step 3 is sometimes the solutions don't work. So hopefully, after these 2 videos, you've gotten a little experience and you feel a little more comfortable working some of these out on your own. So you do have the 1-4 problems on Canvas. Make sure that you work on those and submit them on Canvas before the due date. And if you have any questions as you work through those, let me know. More than happy to help you figure anything out that you might be having trouble with. So I guess until the next video, we'll see you. Have a great day.